Thank you very much. And thanks everyone for coming out. I've actually slightly tweaked the title of this talk since I submitted to be Awesome Automated APIs with Automagic REST. And we'll get into why that change has happened a couple slides down the road. So we'll go through some good decisions, some bad decisions, and how we push the limits of Django through this talk. But up front, I wanted to thank some people for the slides. The Practical Dev for the fake covers, Bartek, the wonderful DjangoCon US photographer, for a couple photos that appear throughout this talk, and my colleagues on the Wharton Research Data Services team for making this all possible. This is by no means a one-person project. So, but right up front, let's talk about what is Automagic REST. So it's an open source package we've released at Wharton that allows you to automatically build a Django REST Framework API on top of an existing database with an endpoint for each model. So let's say you have a database with a couple hundred tables of baseball data. Automagic REST will build a Django REST Framework API on top so end users can look at the data without needing to log in or an admin interface, slice and dice the results, export it to Excel without you having to do any hand-holding. And while this might not be your exact use case, some of the boundaries we had to push through this process could prove useful in a whole lot of other areas. So without further ado, howdy, I'm Tim. My pronouns are he, him, his. I'm an IT director of advanced initiatives, whatever the heck that means, for Wharton Research Data Services at the Wharton School. You can find me anywhere as Flipper PA, much like Aaron before me. I am Flipper PA pretty much everywhere, so you can track me down. And I also have an IMDb page, which is kind of amusing because my name is also Tim Allen. But if you want the full story behind that, I can tell you some other time. I'm a Philly Python Users Group and Community Tech Event organizer in Philadelphia. I'm a Pythonista and a Django nut, member of both the PSF and DSF. I'm a fun-loving geek, a hockey fan, go Flyers, a guitarist, and I am owned by a cat. I also really love ice cream, and there's some good stories behind that as well. I started at Wharton Research Data Services back in 2008, so I've been there over a decade now. I also kind of serve as the Python, Django, and Postgres evangelist at the university, and champion Django becoming our web framework of choice at Wharton in 2015. Soon after that, in 2016, we actually ended up hosting DjangoCon US over at Wharton, and I've been an organizer of DjangoCon US over the years, where I was just last week. I'm a Django contributor, and to that, I mean, let me clarify a little bit on that. I consider Django a community, an ecosystem, and a web framework, and I do my best to contribute in that order. If there's time for questions at the end, I'll be happy to take them. Otherwise, catch me in the hallway track or at lunch. So thank you to the PyGotham organizers. Before I dive in, I always want to make sure to put my thanks out there, because putting on PyGotham is a mammoth effort. We have awesome things like ASL interpreters here, which I've never seen at a conference before, which is absolutely incredible. You all do it with love in class. And plus, John B. makes me feel right at home because he looks just like my dear friend Kenneth Love. I'd also like to thank the Django and Python communities, including ecosystem communities like Wagtail and regional communities like the Philly Python Users Group. I'm also pretty open that I'm in recovery. I started using Python heavily in Django right around the time I got sober. And can't thank the community enough for welcoming me with open arms and sort of giving me a new purpose. And most of all, thank you all for being here. If you're new to Python and its communities, I was in your shoes just a couple years ago. So to echo what Kojo said, I think it's really important to welcome the newcomer and let them know that just a couple of years ago, you know, I was brand new and I've made some amazing friends and done some very fun, very cool, and very weird things in the Python and Django communities. And I want you to know that you can do that too. So with all that out of the way, on with the show. So what the heck do I actually do at work? It's a tough question to answer that I get asked a lot, and I certainly can't explain it in 30 seconds, but I'm part developer, part DBA, part evangelist, part DevOps, part cheerleader, and full-time learner. The best way to explain this to you is, though, to tell you what we actually do at Wharton Research Data Services, or WORDS as we call it. So it's a single source for leading global research databases, which was founded in 1992 for Wharton faculty. It was initially provided for SAS. SAS can mean many things to many people, so I'm talking about the SAS Foundation in North Carolina, the statistical analysis software, with Standard & Poor's and CRISP data, the Center for Research and Security Prices. Our first academic client was actually happened by accident in 1997. A Wharton faculty member left Wharton and went to Stanford and realized that was spending a ton of time doing ETL processes rather than actual financial research, and called up his old friends at Wharton and said, hey, how can I get access to this? I'll pay. And light bulbs went off at Wharton because, surprise, surprise, Wharton likes money. And the idea was born, and from there we went. Our first government client was the Federal Reserve Bank of New York, which is right around the corner here somewhere, in 2003. And our first corporate client was Compass Lexicon in 2011. So it's a multidisciplinary service covering accounting, banking, economics, finance, insurance, marketing, statistics, healthcare, and we offer data on entity management and data linking practices. It's available as a subscription service, and initially only SAS was supported both as a language and a data format, even though a few brave souls dove in using C and Fortran. If we fast forward to today, we're still a single source for leading global research databases. But we have almost 500 institutions, including some of these fly-by-night business schools you might have heard of, like Harvard, Stanford, University of Chicago Booth, the non-Wharton ones that, I'm sure they're not going to be around much longer. But 50% of our growth has actually been international over the past 6 years. When I started, everything actually ran on a single Sun E20K, which was this box that we maxed out the RAM CPU on, and we're still at 100% capacity. It was about 8 feet tall, 20 feet wide, and 6 feet deep, and took up the greater portion of a data center. And what this does is supports, right now, currently, I checked this just before DjangoCon, so 2 weeks ago, we have 63,000 active users who access our service via web, via SSH, directly into Postgres, and via remote connects from client-side applications. We offer SSH support to all of these users on a cloud that we host internally at our own data center, where they can run SAS, R, Python, Julia, and many other languages that we support. We have over 400 terabytes of raw data. That's in the SAS format on disk, and over a 3 petabyte total storage footprint. So we maintain quite a bit of data in several different formats. And we're continuing our expansion beyond financial data. We're starting to move into healthcare data and some other realms too. So to get out of the Sun E20K, we moved on to using SunGrid Engine with LDAP across a sea of white boxes backed by a NetApp. And as you can imagine here, the permissions in ACLs are a huge concern for us. Each of our 500 subscribers have a different set of the over 300 data products that we offer. And it's all a la carte. So Harvard doesn't have the same products as Stanford, doesn't have the same products as Yale, doesn't have the same products as NYU or Columbia here in New York. Over the years, we made some very, very dubious database decisions. Because on the Sun E20K, we had all this research data in SAS format where the equivalent of each database table was literally a file on disk. We also had a MySQL database back in the day to literally run the website, to keep track of our users, what web queries were being run, things of that nature. And we started a website conversion in 2008 that brought in SQL Server, Wharton's then preferred database, and MySQL was never fully retired. The spoiler alert to all this, of course, is that Postgres has made our lives much, much better. But all of our research was stored in SAS in this sort of cryptic, arcane format called SAS7BDAT. We had MySQL for the website data. We had SQL Server after this transition project in 2008 for website data as well. And we had managed to get all of this research data, except for the New York Stock Exchange Trades and Quotes database, into Oracle. So the New York Stock Exchange Trades and Quotes database is our biggest challenge. Out of our total footprint, this is about 70% of the total storage size, because it's literally every bid, trade, and quote that comes across the NYSE. We have it, down to microsecond accuracy. And while each one might seem very small, it's just 8 or 9 columns, it is a very, very tall, tall, tall table in the database. So that was a challenge to get into any modern database. We attempted to store all of this research data in Oracle, as I mentioned, and it kind of worked. We were able to get a web data browser going without any permissions for individual users, so the permissions had to be handled through the web layer. We couldn't allow them to connect directly to Oracle. And we never got the New York Stock Exchange Trades and Quotes in. Oracle we could never get it to quite work. We'd do select queries, and they would just never finish. And again, the permissions weren't handled for our individual users. We only had a service user and then enforced them on the front end. And I'm not saying this to slag any of the other databases that I've mentioned. I've worked with many of these databases. They have a lot of great use cases. They just weren't right for this usage profile at all. So on the permissions front, Microsoft, of course, wanted us to go all in on Active Directory. Oracle wanted us to go in on their solution, OID. All of them had kind of promised that it would work with our open LDAP, but we never got to that sort of promised panacea. The reality was very different. So enter Postgres. So when Postgres came around, the head of our division had a lot of apprehension about throwing yet another database into our mix. Because at this point, we already had SAS, we had MySQL, we had Oracle, we had SQL Server, and if you include LDAP, we had BDB. So we had like 5 different databases, and he's like, what the heck are you doing to me here? You're talking about bringing in a 6th. I've heard you say, oh, this is going to be the promised land, and it never quite happened. But we promised we'd eliminate at least one of these others within 6 months. And we managed to do that. So we started playing with Postgres, and we replaced Oracle for the web data browser and got the New York Stock Exchange Trades and Quotes database loaded with Citus Data's columnar store extension. If you're working with really big data, it's a wonderful extension you can use in Postgres. So at that point, we were able to say goodbye to Oracle. And soon after, we shuttered MySQL from the legacy website and also shuttered a WordPress satellite site we had in favor of Django and Wagtail taking their place, which was also backed by Postgres. So we were starting to keep our promises here. We also managed to get integration with LDAP and our permissions and ACLs working so we could allow our 63,000 users direct access to Postgres. This was huge for us because we could now pretty much say, bring your own tool of choice. We had a lot of people wanting Python, R, Julia, languages of that nature. And this allowed us to say, hey, bring whatever you want. As long as it can connect to a database, you can use it. Stata, MATLAB as well included. So we are still in the process of migrating our main website to Python and Django, but we're way over the tipping point where more is done in Python and Django these days than anywhere else. And we are slowly but surely getting rid of these 25 years of legacy systems and a ton of technical debt. It's been working out really wonderfully for us. So onto the API. We've now, over these years, really built a foundation that we can build an API on top of. This was never possible before. So Django REST Framework is an absolutely wonderful package. And I'll explain some of the jargon as we go along, just in case there's some newcomers. But basically, we had created words in 1992, or somebody else had created words in 1992. I was not around at that time, to dump data from SAS to Lotus 123, the spreadsheet software of choice at that time amongst the Wharton faculty. And fast forward to 2018, 2019, we've created this RESTful API around it. So I mentioned Django REST Framework. It's absolutely amazing. It sits on top of Django and allows you to, in a fairly straightforward manner, on top of your models, create serializers, views, endpoints, and handle permissions for all those endpoints. So you can provide a RESTful API to your end users. The code we generated with 60,000 endpoints was done by introspecting Postgres. So we have a total of over 300 different products. Each of those lives as a schema within Postgres that we can apply permissions to. Within them are a ton of tables, over 60,000 at this point. Hand coding these models, serializers, and views would be nearly impossible. So we wrote a routine that actually introspects the tables to build out the models, and then also wrote routines to handle the serializers and views, so it doesn't have to be done at hand. This is what we've managed to open source this year since the first time I gave this talk when it actually was not open sourced yet, and that was just sort of on my wish list. So starting now, a lot of these features you're going to see coming up, you can add to your own website or to your existing Django REST Framework app and move forward with it. So the web browsable endpoints are all permitted by user. We built in a shim to inherit the permissions that are applied at the Postgres level to the framework. So it really is a plug-and-play interface. We also built out a routine which will automatically add filters and searches to the RESTful API endpoint by introspecting the indexes within Postgres. So it will find the first column of every index within the website and make the appropriate field within the model a filterable field within the API if it is an indexed field in the underlying database. So how did we build it? The first step was to do some field mapping. So we literally took, and if you look here, this is just a Python dictionary, where on the left we have a list of all the available Postgres field types and the appropriate Django model field that we mapped each to. So this was a fairly straightforward process, but we had to do a couple things and make a couple decisions here. You'll notice the squiggly brackets for format insertion that are in place here. We actually insert a couple things here. The first squiggly bracket is to assign a primary key. And since we're doing this in a read-only fashion, we kind of cheated and just said the first column is a primary key, because that's a requirement in Django. But if you're not doing any writes, you can get away with pretty much making anything a primary key. So we created this Django management command to actually build out all these models by introspecting the data database, which we added as a second read-only database to Django's databases definitions. We also had to account for reserved words. So as it turns out, words like yield and finance yield and return are frequently used in finance. They're not just for Python users anymore. And we had sort of an ultimate namespace collision here between Python and the finance world. So what we did was we came up with a list of all of Python's reserved words, which you can actually pull out with just a couple commands in Python. And we made a full list of it. So it's not actually hard-coded. We do actually pull it out from the current list of Python in case that ever changes. And we also added on a couple words to this list that are from Django REST Framework reserved, like format, limit, and offset, that we didn't want to be handled at all. And I know the Python pep8 recommendation is if you have these namespace conflicts to just put an underscore at the end, but we actually put underscore var to make it a little bit more clear, because our end users might not be Python programmers. They might be PhDs in finance. And it's explicit is better than implicit, won out over pep8 on that one for us. So after the reserved words were built up, we ended up with an end result of models. And we used a few hacks here, but we ended up with 60,000 models and it worked. So if you take a look here, you'll see here's an example of how yield var was put into place. You'll see that we appended the underscore var and then used Django's facility to actually map it back to the field. And this is one advantage you might get if you wanted to build out an automated API from from a system like ours. Since we have 60,000 models from over 300 products from over 50 different data vendors, we've run into a lot of edge cases like these and handled them that you might not have run into right now, but you might run into in the future. There's also this beautiful little hack down here, which is how we use multiple schemata. Django doesn't officially support multiple schemata yet. We were talking about it last week. There's not a super high demand for it, but that's actually how we fake out the automatic quoting system of the ORM. It is not pretty, but I think it's important that we call out hacks when we do them like this, because we do come to rely on them. So as you'll see, I actually made a note to note that. So this actually worked. We now had 60,000 endpoints. We had permissions in place, and things were pretty wonderful. We were feeling pretty good about ourselves until we ran into some big data problems. And with the amount of data and endpoints, we had quite a few interesting problems to solve. So it turns out when you have 60,000 models being imported and checked in Django, that causes really long system checks to occur. So when I ran Python manage.py run server, it was taking several hours to spin up, and the site would just sort of hang there whenever we'd publish to production. So we had multiple nodes, and we'd go ahead and publish, and it would be 2 hours or so before sort of the system checks and caching had come into place. We also had the permissions problem again, 63,000 users across 500 subscribers. We had to make sure that end users only had access to what they should. So at the initial point, it was up. Everybody could get to everything. We also had a count problem. So some of these tables have millions and billions of rows. And Django REST Framework, one of the more popular ways of paginating within Django REST Framework is limit offset pagination, which requires a select count to know how many rows there are actually in the table to give accurate page counts. These would take sometimes over 5 or 10 minutes, which was really not acceptable to us for an endpoint with our larger tables. So we had to figure out a way around that. Filters I touched on a little bit, but how do we automatically create them? We didn't want to do any manual touch-ups of these 60,000 tables, because that would be a couple full-time employee positions in addition to our team that already handles all this data on ingress from our data vendors. So we didn't want to, require more manual effort to do this. And we also had the problem of, I don't know if you know this, but finance folks have a really scary, loving relationship with Microsoft Excel. It's kind of like if they were asked, okay, do you want to give up your children or Excel? They'd have to think about it for a few minutes. It's bordering on frightening and pathological, but it's there, and I am not going to be able to change it. So finance folks really love their spreadsheets, so how can we let them get their data into Excel as quickly and easily as possible through Django REST Framework? So what we did, we came up with a way for the first problem, the 60,000 models being slow problem, of overloading base names. So every endpoint within Django REST Framework that you register requires a base name that has to be unique. So we overloaded this base name by including the Django database definition name, the app name, the schema name, and the table name, which would always be unique, but also gave us the information we needed in a convention for putting together a model, serializer, and view for each endpoint. We then did a trick we then extract those values in the generic viewSet class that I've built here. You can see we're within class generic viewSet. The self DB name, Python path name, schema name, table name equals split base name. We just split them apart by the period and got the components we needed. And then did this trick where we got the API model and the serializer using this getAtterImport module function. What this does is actually imports it at runtime of the view. So what this allowed us to do was kind of create our own form of lazy loading to get around Django's system checks. And after doing this, run server would come up in about 30 to 45 seconds instead of the several hours I mentioned before. So this worked out great for us, and it actually made it so we could develop without wanting to pull our hair out and making 1 or 2 changes a day and waiting for run server to come up, and then realizing that I made a typo and having to go through that whole process again. It made it actually workable. So this, we did know that this was going to cause us to run into some potential errors in production that we might not run into otherwise at runtime instead of during the system checks, but we decided that was a trade-off we were willing to accept. So handling permissions, this was another interesting one. So the underlying database that we had built that was backed by LDAP across the board for the web, SSH, and Postgres access I had mentioned before, we decided we were just going to extend this permission to the API as well. So yeah, I'll reiterate, we are quite insane. We do give 63,000 actual users SSH access in Postgres. The security implications of that are a topic for discussion at another time. But at this scale, permissions have to be automated for each user and subscribing institution. So we've got the permissions in Postgres. We were able to inherit them for Django REST Framework by just adding this shim right here, where you pass in a username, a schema name, a table name, and it will actually run the underlying Postgres function to see if the user has access in Postgres. And if they have access in Postgres, we give them access to the same API endpoint that matches the table. Permissions are applied at the schema level, and this shim has worked wonders for us. And again, we plugged it in, and much credit to Django REST Framework with its extensibility. It allowed us to just write our own Django REST Framework permission with this check in it, plugged it in, and it worked. Moving on to the speeding up slow count problem I had mentioned. So when you have millions and billions of rows, that select count problem is a big one. And we racked our brains trying to come up with a way that we could get around it. So one of the first things we thought of doing was Postgres actually does store, as do most databases, an estimate of the total number of rows in each table, in a metadata table. However, that would only work for the size of the entire table. As soon as you insert any filters, which become where clauses, that number isn't worth it. So we had the thought, what about the explain query plan? What if we can tap into the query planner? And that's exactly what we did. So when you do an explain with a query, it will give you an estimate of how many rows it thinks it'll get. And it's not exact, but again, it just absolutely worked for us. So we had actually written a full function to do the estimate count by passing in the full query that was going to be run by Django at that time. We ran into some other problems there that I'm currently working on a pull request with. But like manna from heaven in Django 2.1, query set.explain was added, which passes you the text of the underlying explain syntax. So all we had to do was parse this text that gets returned to see the estimated number of rows. So what we did is we wrote our own pagination that was a subset of Django REST Framework's limit offset pagination called count estimate pagination. And what we did in our view, at the top part that's highlighted here, is we ran our own select star, explain select star from schema name and table name to see if the estimate thought there were more or less than 1 million rows. And if the estimate thought there were more than 1 million rows, we set our pagination class to be count estimate pagination. So in this way, if the estimate thinks there are less than 1 million rows, we say, okay, use the accurate select count. If it thinks there are more than 1 million rows, let's use the limit offset pagination. 1 million seemed like a nice round number to do the cutoff on. And this has worked out pretty well for us. The count estimate pagination works really well, and in our tables with billions of rows, you know, at the end user's perspective, you can see the different pages, and it will be going off to page counts in the millions. And if you click last page, you might get a blank page and have to click back 5 or 6 times to get to the actual page with the last data. But when you're talking billions of rows, I think that's an offset that I'm willing to take, rather than having the end user wait 5 to 10 minutes for a completely accurate count. And this is the same thing that a lot of service providers do. You know, when you go to Google and you put in a search term, it says, you know, results 1 to 20 of approximately 2.7 million results. That's them basically doing the same thing to avoid needing an exact count and getting the estimate. So it worked out really well for us there. And this, again, is available as part of the package. So filters on index columns. This was another interesting problem to tackle because we didn't want to have to go back and say what users can we, what fields can we allow users to actually search by? What can we allow them to, you know, slice and dice by? And we came up by introspecting Postgres' information tables with this query here, which is not the prettiest thing I've ever written, but it seems to work. And it selects the first column of all indexes within the table, the first column being the one most important for sort order. So we decided for any of those fields, we will go through, and depending on the field type listed here within Django, we'll add the appropriate kinds of filters. So for car fields and text fields, we'll allow it to be searched, but also we'll allow it to be filtered by either exact, contains, starts with, or end with. And if it's a numeric or a date field, we'll allow it to be searched by exact, less than or equals, greater than, or greater than equals. So this gives our end users flexibility, which I'll show to you in a minute. We also use a separate third-party package called Django REST Framework filters rather than just Django filters, which gives some extra types like complex filters and compound filters. So we can actually allow our end users to use and or logic in their API requests, giving them some pretty nice control of the result set they get back. So back to the finance folks and their unhealthy love of spreadsheets. So we've now got a way where users can slice and dice their data, but how do they get that into the spreadsheet? So what we looked at was Django REST Framework ships with several renderers. So people have probably seen the browsable API renderer that you can surf through. JSON, of course, which is the most popular for getting the actual data from a RESTful endpoint. You can also pipe it into Django HTML templates. They're rendering layers for the admin. So what we decided to do was build one that would just output Excel. So literally, we wanted to make it so any endpoint you have, you can just change the format to XLSX and have it dump out an Excel binary. And we did that, and we've open sourced it. So you can add that to your Django REST Framework project today. It's called DRF Renderer XLSX, because I'm about as creative in my naming as Aaron Bassett was before me. Apparently, neither of us come up with very creative names, but it just works. And it can be pip installed. So I'll give a demo of how to do that in a minute. So we had quite a to-do list to go through. This had initially kind of started as a skunkworks project that I was working on, and then a large Fortune 50 client we had wanted it yesterday, so it suddenly became a priority. And around the office, instead of people saying, so what the heck are you doing over there, Tim? What are you working on? It became, oh, I get it now. And Django REST Framework and Postgres let us address this need really quickly. From the moment that Fortune 50 client wanted it to getting it out the door was just a matter of a couple weeks for the first version, which we've continued to find. But there are a bunch of things that were still on our to-do list, like cleaning up the cursor.execute methods and properly parameterizing, switching to Django templates for code generation instead of using a whole lot of .format commands. This was before we had adopted f-strings in Python 3.6. We wanted to abstract the hard-coded values for our specific system to settings and methods. And we wanted to create pip packages for the features beyond the XLS export and release it to GitHub and PyPy. And I can now say that this is our done list. So we have managed to knock all these out and release it. And so I want to say thank you to PyGotham and pray to the Wi-Fi gods, because let's try to do a live demo here. I love living on the edge, so we'll see if this works. It did at DjangoCon, so hopefully we have the same good vibes that we had over there. But really, seeing is believing. So I think showing the live demo of this shows what really can be done with it. So I will go ahead and bring this up. So voila. Let's see if I can refresh it. Okay. So this is actually, I will embiggen this. It's a perfectly cromulent word. You'll see here that when you log in, this is what our end users get. And we've gone ahead and created documentation here sort of as a basic starting kit. Because, again, these are PhDs in finance. A lot of them sort of dabble in coding, but aren't really big coders. So what I've done here is given them fully runnable blocks of code. So we actually include their token here, which I'm sure is making Aaron Bassett giving his last talk some night terrors. Because it's so easy to, I could copy and paste this right into my Twitter feed and you'd have my token. By the way, enjoy my token for the next 30 minutes or so before I change it. Hello, PyGotham, hello, PyGotham, hello, PyGotham. And this gives a full example to them that they can copy and paste to the command line, run, and actually get some results. But it's not very interesting data. So this is a free data set from the Philadelphia Stock Exchange, publicly available data that all our customers use, so I often use it for demos. But it's not nearly as interesting, and this will take a second to repaint in the browser, because I will show you now what 60,000 endpoints look like. So you can see here, right up top, we have AHA, which is the American Hospital Association, followed up by Audit Analytics. And if I start crawling down, be sure to pay attention to, oh, you can't quite see it. I was hoping you could see the scroll bar on the right. Let me make this a little smaller and not maximize so we can actually see how far down I'm going, because this is what 60,000 endpoints looks like. So if you look to the right of the browser screen, oh, I made a mistake by resizing. It's going to have to repaint. It'll just take a sec. There we go. You'll see as we scroll down, we're barely making a dent into where we are. Okay, we're up to the CIs now. And you'll see there's comp for CompuStat, and I could keep going and going and going. But you get the point that it's a very big page. So through the magic of television, we're going to skip that. And you'll see here, the page I've come to is CRISP, the Center for Research and Security Prices, DSF, or daily stock file. So this is something that everybody can relate to. This is end-of-day pricing data for all major American companies. So you'll see here that we have 10 per page, 9.4 million pages. So we have about 94 million rows in this table. And the select count problem would have existed, but this will be using our count estimate pagination. So if I hit refresh, you'll see, bam, it's already back by the time I can finish that sentence. So it's very quick. It gives us this count estimate pagination. And let's see, if I go to the last page, it'll take a few because of deep paging, but we'll return in a second. So if we want to look up an actual company that everybody's familiar with, I'm going to look up Apple's QSIP. So what QSIP is a unique identifier. Tickers change over time. So most people know that Apple is AAPL on the stock exchange, but those can change over time. So if we look at the QSIP for Apple, you'll see I Googled Apple QSIP, and it pops up right here, the 0378310. If I go ahead and look in filters here, you'll see that the automatic filter building I have done has already made all of these filterable by these different type of filter fields. So all of these in the underlying Postgres table are the indexed ones. So if I see 037833310 as Apple, and go ahead and put that into here and do a search, you'll see returns lightning fast again, that here is Apple's QSIP. We can see that Apple first went public on February 4th, 1981. And we can see every end-of-day Apple pricing over time from the API by searching for Apple's QSIP. We also offer all of these operator fields on the appropriate indexed fields. So we give full documentation again on how to do the example and provide an example of how to pass these parameters into our end users. We also show how to use the complex filters. So I told you a little bit about Django REST Framework filters, a great package. It allows us to do stuff like this, where we can actually use some OR logic. So what this does is says, gives me all results from this table for the first month of January 1991, where they start with a C, or anything from the first month of 1995, regardless of when they start. So if I actually pull this up, okay. It'll take a minute to run, but we should see data come flying back, and you'll see, there we go, everything from the first month of 1995, and if we go back day by day, we should see the first month of 1991, where they start with C. And there you go, you can see we got them. So like I said, it just seems to work. Now if we come back to Apple here and we want to see all of the time that we have for Apple, and we want to get this to our beloved Excel spreadsheet, you'll see I've limited these to 50 per page and have the QSIP in place. But over here you'll see under the get option that we now have JSON API and XLSX. So if I go ahead and click SLSX, voila, it's given me a download. And here's the moment that I always get nervous, like, did it actually work? Let's see if it actually opens up in a spreadsheet. And voila, there's all your end-of-day pricing for Apple throughout time. You can scroll through it, slice and dice it any way you like, and we have the data. So we also give some examples of how to use this in JavaScript. To grab the JSON to do actual pagination and progressive loading to help people learn as they go along. But if you want to see how this actually looks within our website, so on the web front end, here's the web query form that we offer to our end users to be able to actually run queries against this data. And I'm going to run a quick refresh because we have a quick timeout on our sign-in. But if I come over here to dataset list, you'll see this is the web front end we actually have. So if I come back here and grab Apple's QSIP again and run the same example on the front end, you'll see here's all the crisp daily stock file data on the front end. This is being powered by the API. If I come in here, I can now add some logic where the QSIP is equal to that, apply these filters, come back to the data table, and you'll see same QSIP here. Here is all of Apple's pricing. Whoops. little too quick on the draw there. So if I go ahead and put the QSIP in and apply the filters, come back to the data table, you'll see that the QSIP is the same. And if we look at the dates, you'll see February 4th, 1981, the first starting date. It's actually pulling through the API from the back end and presenting it on the front end layer. So that kind of shows you end to end where we started in 1992 all the way to 2019, what we can do now, and how we're actually bringing our organization into the new millennium slowly but surely. So if you want to learn more about Automagic REST, it's available up on PyPI. It's also on GitHub. Again, I don't think this is a use case for everybody, but it might be worth looking into the code because we've done some tricks in here for a very, very large back-end installation, which might be able to help you out. You can also look up DRF renderer XLSX and install this tomorrow. It's under the Wharton GitHub. We open source a heck of a lot of what we do over at the Wharton School. And the installation is fairly straightforward. You just add it to your renderer list. And then within an example view set here, you'll see we provide a mix-in, so you can provide a file name that you want it to be downloaded as. That needs to be added to the content disposition for the download. Otherwise, browsers often resort to just calling it download. So you'll see we allow you to specify a file name and then add it in as a renderer class, and you're good to go. And we've also, if you want to get really fancy, you can add Excel spreadsheet styles, which I haven't worried about yet, but that's a feature as well. So if you're looking to add spreadsheets to your endpoints, you can have a look right here and get started. So that's all I got, but hopefully that's shown you a couple tricks that you can do with DRF, and if you have a lot of big data, that's one way to get it out there. Thank you all so much for coming.